Hey guys, so y'all spent the last couple of days reviewing weathering, erosion, and deposition. So the reason I had y'all do that is because now we're going to be looking at how those processes, weathering, erosion, and deposition, how they change Earth's surface over time. How weathering, erosion, and deposition can change or affect the topography of the land. So when I say topography, that just means like the shape of Earth's surface. So we could be talking about an area with a very flat topography, like in the plains, or a topography with rolling hills, or a very mountainous topography. And so those processes, weathering, erosion, and deposition, can change how landforms are over time. And so one way that scientists can track those changes is by using something called topographic maps. And so I wanted to show you a little demonstration today. You're going to need Play-Doh if you want to do this along with me, some dental floss, and a ruler, and a piece of paper, and a pen. If you want to stop the video, go get those things and come back. If not, you can just watch the video. This is definitely something we would have done in class. So it's heartbreaking that we don't get to do our normal thing, but we're going to do the best we can. So let's see. So I already got out my Play-Doh, and I made a mountain. So I'm going to put the screen down. Okay, so I made a mountain, and I made this mountain really steep on one side and not very steep on the other side on purpose because I know what I'm trying to show y'all. It's going to be easier to show y'all with a steep side and a not so steep side. So I'm going to pick up the mountain and let y'all see a little bit better angle. So we've got the steep side. So I would say this is the south side of the mountain. This is the north side of the mountain. Okay, so the north face of the mountain is easier. If you wanted to climb up the mountain to the peak of the mountain, which is the top, it would be easier trek up this north side of the mountain than up the south side of the mountain. Okay, so let me show you how a topographic map works. So we're going to take our ruler, and my mountain is about 2 inches tall. And I'm just going to make a little mark on the south side at like a 1/4 inch. And this is kind of hard to do perfectly. And then one at about a 1/2 inch. And then one at about 3/4 of an inch. One at about 1 inch. About 1 1/4. And our last one at about 1 1/2. Okay, so I've got these little indentions. Little marks right there, and that's going to tell me where to cut. Okay, so we're going to use dental floss to cut some layers into this of this mountain. Okay, so the first thing I'm going to do is this top indentation that I made right here, this top dot that I made. So I'm going to wrap the dental floss and try to keep it very level as I wrap it around. And then once I kind of have it wrapped around all the way the same elevation, so elevation is the distance above sea level. Once I have the dental floss wrapped around pretty much as close as I can get the same elevation all the way around, I'm going to like pull the floss through. Now it kind of messes up the shape a little bit, but just do your best to keep it together, okay? And then I'm not going to turn this piece or anything as I pick it up and I put it down on my paper. Okay. All right, so that's my top layer. Okay, my next layer down, I'm going to do the same thing. Wrap it around, pull that slice through, and I'm going to lay it next to it without turning it or rotating it. Then my next slice. So you can see I'm just slicing up this mountain into layers, and each slice is like the same elevation from the base of the mountain. Elevation meaning how high it is. Another slice. All right, I think I'm going to do a couple more here. This is quite satisfying to slice floss through a nice new Play-Doh. Okay, and then we'll do one more slice. Maybe. It's kind of hard to do once it's Gotta get this last slice. Possibly. Okay. There we go. Okay, so we've got 1, 2, 3, 4, 5, 6, 7 slices of our mountain. I'm gonna leave this bottom one where it is. I'm gonna get my pen or pencil or marker, and you're gonna trace around the bottom one. Okay. Whoops, I got a little marker in my Play-Doh. Okay, and then I'm gonna take it off. Okay, so I'm gonna kind of hold that up so you can see. I know it's upside down a little bit, but that's what it looks like. And then I'm gonna take the next layer up, put it right there in the middle, trace around this next layer. Now I'm gonna take that layer, remember I'm not rotating any of these layers, I'm keeping them the same orientation. Put it back up where it belongs on the base of the mountain. Okay, take the next layer, don't rotate it, just put it directly on to the middle of that outline you just drew. Whoops. Okay, next one. So I'll kind of speed up this next process. You know what I'm doing. I'm working my way up to the top of the mountain. It gets a little messy here with the Play-Doh. And the last one. Put it right there in the middle. Okay, so here's what I ended up with. Okay, so these are called contour lines. Contour lines connect points of equal elevation. So this outer outline, that outlines the whole base of the mountain. So the whole outer outline is what we could call like 0 elevation. It's at the base of the mountain. Then you go up a little ways, and then that's our next contour line up, and every point along this line is the same elevation up from the base. Then we go up to the next line, that's a little higher elevation, a little higher, a little higher, a little higher, a little higher, and then right there, we're at the peak. I put an X right there. So that X means the peak of the mountain, the top of the mountain. So we've just made a topographic map of our little Play-Doh mountain. And you can tell something from this map, the way the lines are. These contour lines can give you a clue as to where it's steeper and where it's not so steep. So remember, I had one side that was steeper. It looks a little weird now. One side that was steep and one side that was not so steep. The not so steep side was the north side. So my paper's kind of flipped around now, but you can tell the steeper side because the contour lines are closer together. So this right here is the steeper side, and then this right here where these contour lines are spread out further and further, this is the side that would be easier to climb up to the top of the mountain right here. Okay, so that's a little bit about how a topographic map works. The lines are called contour lines, and contour lines, okay, flip it around now, contour lines, and then the distance, or I'm sorry, the difference, I put a little arrow between these two. The difference in elevation between contour lines is called a contour interval. Okay, so let's say our first line that we traced, this outer one, was 0 inches. Okay, and then the next one in was at 1/4 of an inch. Okay, so the contour interval, the difference there is 1/4 of an inch. And actually every contour interval is 1/4 of an inch because I marked off those dots on my Play-Doh mountain every 1/4 of an inch. So the contour interval for this map is 1/4 of an inch. Every topographic map will have its own set interval. Mountains are not inches tall. They are many, many, many feet tall. So on a real topographic map, your contour intervals are going to be in a certain number of feet, maybe 100 feet. Okay, so a little intro about topographic maps. I know that was kind of long, but this is a really good visual way to kind of imagine how contour lines are lines that connect equal elevation going around a landform. Okay, bye.